the way. Oh yeah, today we're gonna talk about what? Lattice energy and I think lattice energy, chemical energetics. So what we're gonna do today is to cover lattice energy. What's lattice energy? Oh, she's my ex-student by the way, my A-star chemistry student. So what's lattice energy? Please add it in. Yeah, so what we're gonna do is to cover lattice energy, cover Born-Haber diagram, and by the end of the lesson, you should be able to do all the chemical energetics question. We're gonna go through it slowly. Do you have anything to say? Tips given to the junior.
Just study.
Just study.
Just watch the video.
Just watch the video. Okay. Yeah. Anything else?
No.
Okay. So we're gonna move right into the video. So guys, for Born-Haber cycle, right, it's basically a type of energy cycle used to calculate your lattice energy. Chapter 20. Yeah. Now, okay, so for your Born-Haber diagram, right? Okay, so guys, I want you guys to put it down. So whenever you are drawing an exothermic progress, okay, any reaction that's exothermic, right? Okay, arrow always go down. Guys, but okay, page 6. But when you have any endothermic reaction, your arrows always go up. Alright, guys, you see, right? To construct your Born-Haber diagram, yeah. First, what I want you guys to do, right? I want you guys to draw a ground state. And after that, state the product. Alright, then guys, for your second step, right? What I want you guys to do, please form our delta H lattice on the right hand side. And your delta H, okay, formation on the left hand side. The step. Last week, yeah. No. I don't see any Kluger. I just saw him alone. Maybe she was downstairs or something. Alright, guys, connect your delta H formation, okay, to delta H lattice. Okay, you guys need to connect your delta H formation to your delta H lattice, and guys, label all the delta H. Box that clockwise equals to anti-clockwise. What do you mean clockwise, anti-clockwise? Later I'll show you, don't worry. Okay, there's one thing that you need to know. Where's Chantal? Where's Chantal? Skipping up. Okay, guys, again. Okay, I want you guys to write it here to relate our bond energy. How's party today? To delta H atomization. It's okay lah, I don't care also. No, she never. Okay, so guys, let's look at your how Chantal. Hey, Chantal is here. You see, kid, let's say, right, if I have 1 mole of chlorine gas, okay, so you see I have 1 mole of chlorine gas, Cl. And guys, if I break it down, right, what do I get? I get 2 Cl gas, correct? So this value that we have, right, this is bond energy. Understand? Okay, how do you convert your bond energy to delta H atomization? Remember, yeah, your delta H atomization, right, always stand for 1 mole of atom form. So guys, do you see that this is 2 mole of atom? So this entire equation, go and divide it by 2. So you get half Cl turn into 1 Cl atom. Okay, this value, we take bond energy divided by 2. That is your delta H atomization. So guys, you know the difference between atomization and bond energy? Bond energy is you're breaking a mole of molecule, 1 mole of molecule. Atomization, you are forming 1 mole of product. You are forming 1 mole of atom. Clear? So guys, to relate your atomization to bond energy, put it here. Atomization is always half the bond energy. Alright, given that, right, delta H atom of sodium is 107. Okay, first ionization energy of Na is 494. Then EA of Cl is negative 349. Formation is negative 441. Bond energy is this much. And I want you guys to calculate the lattice energy of NaCl. Okay, so a minute. I'll wait for the 2 kids to come back. Then I'll continue. You guys can read the question first. Alright, guys, first, okay, I want you guys to draw a baseline. Okay, draw a line at the bottom and label your product. What are we forming? Sodium chloride. Okay, that's your first step, yeah, guys. I'll slowly guide you on drawing your Born-Haber cycle. Alright, guys, after drawing your ground state, right, second step, please form lattice energy on the right, formation on the left. Lattice energy about, okay, on your right. Okay, so this is delta H lat. Alright, guys, should remember what is lattice energy. Lattice energy is from a gaseous ion combined into a ionic solid, right? So gaseous ion combined NaCl. Okay, delta H lattice on your right hand side. Alright, guys, what about your left hand side? What do we put? Left hand side is your delta H formation, right? Again, your left hand side, that's your delta H formation. So, guys, left hand side. And guys, how to form? So, to draw your formation, right, it's always okay, you have to get, for example, right, I need NaCl. Definitely, I need 1 mole of sodium, and sodium under standard condition is solid state. And guys, where do we get Cl from? We get Cl from a chlorine gas, and under standard condition is a gas. Okay, and I can put a half here. Yes. Right now, let's look at sodium. Okay, how do you turn sodium solid into sodium gas plus? So first step, right, guys, I need to atomize our sodium first. Up. Alright, guys, solid sodium turn into a gas sodium, yeah. So that is your delta H atomization of Na. Understand? So guys, you have to slowly convert, yeah. This I have to slowly convert it here. So sodium, I convert the state first. Now you see sodium gas, sodium gas. Alright, guys, you have to convert it by adding a charge. How do you turn sodium into sodium plus? What's the process? Na to Na plus is a first ionization energy, right? So right now Na plus, correct? So guys, do you see that Na plus? Na plus is the same already. Good. Right now, I just have to turn my half Cl2 into Cl minus. Okay, nice. Guys, I can turn my half Cl2 into a Cl atom first. Huh? This is still Na plus gas, Cl gas. Okay, so this is my, what is this? First IE, and this is your delta H atomization of Cl, right?
What's the name people?
Guys, next. Okay, from Cl gas to Cl minus, what is the process? This process is first electron affinity, right? That's it, guys. Okay, now your entire diagram is completed. Now, I want you guys to plug in the value. What is my value? Atomization is 107. Plug it in. First IE is 494. Electron affinity is a negative. Arrow goes down already. Negative 349. Formation of NaCl, negative 441. Okay, next. Bond energy of Cl. So guys, how to turn bond energy into atomization? So guys, this is atomization. So atomization is half times your bond energy, right? Half times 242. And this is my lattice energy, which is at X. Okay. Okay, guys, once done. Okay, the last step is clockwise equals to anti-clockwise, right? Guys, where's my clockwise arrow? You see, all these arrow can be combined, right? These are your clockwise arrow. Can I see that? Can you see that? So these are your clockwise arrow, right? One more time. Clockwise arrow, right? You can see that. You can combine everything, right? So everything here is a clockwise arrow. Where's my anti-clockwise arrow? It's only this way. So this is my anti-clockwise arrow.
Yeah, but you can just do it with them.
Good. All right, guys. Now, can you apply clockwise equals to anti-clockwise? Find out X. Go. So, guys, can I say that 107 plus 494 plus half multiplied by 242 plus negative 349 plus X equals to what? Negative 441. Guys, find out the value of X. What's your answer, guys? Negative 814, right? You guys get the answer?
Is that what you're saying?
Note that arrow always going, okay, arrow going up always represent an endothermic. Arrow going down always represent an exothermic. Yeah. Okay, guys, go. So find the first electron affinity for chlorine. Go. Look at this question. I want you guys to find the first electron affinity for chlorine. Get me the answer now. Guys, let's draw the diagram. Now. Let's go. Draw the diagram. So one side is gonna be delta H lattice, right? Okay, and delta H lattice is always from gaseous ion. So Mg2 plus gas, 2Cl minus gas, correct. And lattice energy is negative 2526. Next. So this is delta H formation next. So for delta H formation, I have magnesium solid plus a chlorine gas. As for formation, MgCl2 is negative 641. Alright guys, first step done. Second step, you have to slowly combine, slowly connect them. Okay, go. So from magnesium, solid turn into a magnesium gas first. What is this? That is the delta H atomization of Mg, right? Correct. Value. 148, right? Alright guys, after that.
It's so mean to me.
Alright guys, next. Mg turns into a Mg plus, right? So this is your first IE, right? Then guys, how do you turn Mg plus to Mg2 plus? Your first IE value is 738, right? Put it down. Next, what else? Mg plus turns into N. Well done. My second IE is 1451. Done. Okay. Okay, guys, now my Mg2 plus done converting. How do you convert Cl2 into 2Cl minus? Guys, I have to atomize it first, right? I have to turn it into a Cl atom first, correct? So how many Cl atom we are getting? 2, right? Am I right? Guys, atomization is producing 1 mole. So since it's 2, it's going to be 2 times atomization, yeah? Two multiplied by 122, right? Alright guys, finally Cl turn into a Cl minus. What's your answer? So guys, this would be your electronic affinity times how much? Times 2. Why? Because 2 mole of Cl turn to a 2 mole of Cl minus. So 2 molecule of electrons, 2 mole of electrons needed. Go. Okay, guys, after labeling all the values, please find out what is my value for EA now. Negative 348. Well done. 64148 plus 738 plus 1451.
You're funny stuff. Look at what she said.
Sorry.
Nosy beach.
Sorry.
Okay, I'll tell you. Oh, you're gonna tell jokes, man.
This is my friend.
You're not sweet.
Alright guys, what's your 2x?
No, she's not gonna say anything bad. Because, no, what can she say bad? She can say good things.
2x equals 696, right?
Why would she? You have a lot.
Check your answer, guys. Let's go. What's the next page? Alright guys, now I want you guys to skip everything. Shh. Page 21. We have delta H solution, guys. Let's go. Look at delta H solution, kid, everyone. Alright guys, when an ionic solid dissolve in water, okay, the crystal lattice break up and the ions separate. Okay, so it requires a lot of energy to overcome the forces here. So now let's look at the definition. So the definition, we call it as enthalpy change. When 1 mole of ionic compound dissolve in sufficient water, okay, to form a very dilute solution. Let's go. Okay, so 1 mole of ionic compound dissolve in sufficient water. Keyword. Form a very dilute solution.
No, I see my mom keep calling me, I'm not going to do
Okay, example from solid turns into an aqueous, can see that. Okay, so this can be understood as NaCl turn into a Na plus aqueous and Cl minus aqueous also. Okay, guys, now let's look at a delta solution, right? So, guys, your delta H solution can either be a positive or negative. Okay, guys, now write down a delta H solution. If it's a negative, it's soluble. Most likely to be soluble when delta H solution is negative. And for insoluble substances, your delta H is most likely to be positive. And is there a reason behind this? No. Unfortunately, no. Okay, so guys, I want you guys to put it here, delta H solution. Okay, if you see a positive value, it's insoluble, yeah.
Johnny, can you toss my calculator?
Okay, this is only valid, right,
Trust. Thanks, Dave.
at a specific
Oh,
temperature.
Oh.
Kumi to say, isn't substance with positive are relatively insoluble? Yeah. Positive value insoluble. Correct?
I don't have to say.
Insoluble, positive what?
Thin, right? Dose is thin, right? Yeah, never mind. You're sour. You like Avila.
Get it now, I get it now. Okay, okay, yeah. So here, right, positive value, it's insoluble, right? My bad.
Wow.
Thanks. Alright, guys, this is the last part already. Go. Faster. Come. Alright, guys, finally we have delta H hydration. Yeah. Not done. Faster lah. Now, let's look at hydration.
Yeah.
Okay, guys, for the value of hydration, right, the definition is, okay, the enthalpy change, a second. Yeah. Okay, is the enthalpy change when 1 mole of gaseous ion this time. Okay, when 1 mole of gaseous ion, page 22, 1 mole of gaseous ion dissolve. So fun.
This pants is super bad.
Okay, dissolve in sufficient water. Shukiki. Why is he wet?
Step on the toilet water.
Why is he wet?
You got shit, right? I use my socks and my.
Oh, use your wet socks touch me for what? What the hell? Eee.
No, I wear the slipper. I wear the slipper to go through.
Oh my god.
Bro, it's getting pressed.
Okay, insufficient water to form a very dilute solution. Hi. Your friend lah. What is this lah? Alright, keyword 1 mole of gaseous ion.
She replied, "What are you telling us for stuff?"
Alright, example, guys. You see, from a sodium gas turns into a sodium aqueous. From a Cl minus gas turn into a Cl minus aqueous. Things like that. So these are delta H hydration. And guys, for delta H hydration is always exothermic.
I'm not telling you that to say that. Right?
Formation of insoluble salt.
Say that, right?
Barium sulfate is insoluble.
I feel like your dad wouldn't can.
Alright, done. Alright, guys, you see. Okay, here's the definition. Okay, example, right, guys. Okay, I want you guys to label it for me. Let's say if I have Na plus, right, and plus Cl minus, it turns into NaCl solid. Guys, can anyone tell me what is this?
That's a good thought.
Okay, Na plus Cl minus turn into NaCl. Guys, what is this energy? Gaseous ion turn into a solid. It's a lattice, right? Alright, guys, let's say it turns into, okay, bro, why got equals here? Gas here, bro. Okay, guys, let's say, right, from NaCl solid turns into NaCl aqueous, or your Na plus aqueous and Cl minus aqueous. What this reaction is gonna be? From solid turns into aqueous, is dissolving, right? So we call it as delta H solution. Understand? What about from gas turns into aqueous? From gas turn into aqueous, that we call it as hydration. Understand? Hey, thank you. Okay, so according to this reaction, right, can you see that lattice plus solution equals to hydration? So guys, to rewrite in terms of solution, right, we can say that it's delta H hydration minus of delta H lattice. Okay, this is the formula that we use here in group 5, in group 2, yeah, chapter 25. Write it down, guys. OMG, I'm so hungry, haha.
Okay, so that's all for today's topic. So thanks for watching.
Please like and subscribe.